So the first question says, to predict the flight path of a toy rocket is defined by this relation. So the relation reads this. It says h is equal to -2 bracket d minus 3 and d minus 15. Okay. Where d is horizontal distance in meters from the safety wall, and h is the height in meters above the ground. Okay. So what they're saying here is they have some kind of safety wall. It looks like this. And here's the ground. So it makes sense that the rocket was probably fired from this point, something like that. We'll figure out exactly where it's fired from. Sketch the graph of the path of this rocket. Oh, okay, so that's the very first thing we need to do. We want to sketch this graph. Now, if they want us to sketch it, we have to figure out what our R and our S are, what our x-intercepts are. Can you tell by looking at this what the x-intercepts are going to be?
3.
So we're going to have our R and an S. R and S. Is it going to be 3 or -3? Okay, let me show you a trick here. Technically, what we're supposed to do...
Wait, isn't it always the opposite?
Yeah, kind of. Unless there's a number in front of the variable, we're just going to use the opposite of what the number's in there. Now, if there's a number in front of the variable, it's very different. It won't be that number at all. Okay.
When you have to divide it,
yeah, you have to do a little division on top. So in this case, you're right. It's going to be opposite. So we're going to have, say, R is 3 and D is 15. Okay. So when we go to sketch this graph, right, in fact, we can use what we used above. This is our safety wall, we'll call it. So here's the safety wall. It looks like the rocket was 3 meters. These are both x-intercepts, the R and the S, right? So it looks like the rocket was about 3 meters from the safety wall when it first was fired. So at 3 and 0. And then it gets fired, and it finally lands again 15 meters from the safety wall. Okay. So the person standing back here, what do you think our safety wall would be considered on a graph? Well, actually, let's think about this. Where do two major lines cross? This would be what point? Now, this isn't quite the scale, but this would be our y-axis. We'll use the safety wall as y-axis, and the ground is our x. What would this point be here? Yeah, so it would be 0 and 0. So a person, you think of it like this. They're standing behind a safety wall, and then they fire the rocket. It starts 3 meters from the safety wall, the rocket, and it finally hits the ground again at 15. Okay, so that's the idea behind it. So this is just a rough sketch. We can graph it properly after. Okay, so that was A. That's our rough sketch of the graph. Question B says, how far from the wall is the rocket when it lands on the ground? Okay, so we've already discovered that out twice. We know that it starts at 3 and then it lands where? Where does the rocket finally land when it hits the ground? Because X is our ground.
15.
Yeah. So it lands 15 meters from the wall. What's the problem?
No.
So we're going to solve all of these, but we'll just go do the questions first. C says, what's the max height of the rocket? What's the max height? And how far from the wall is it at that point? Okay. So we got to figure this out. When they're talking about a max height, what part of the sketch are they talking about? They're talking the max height. Where along this parabola are we at a maximum height?
Wait. You don't know though.
So we know the max height is actually also our vertex. So we're going to be looking for our vertex because that'll be the highest this parabola goes. And they also want to know how far it is from the wall at that point. Now, when we're in factored form, which we just were, okay, let's remember this is our factored form here. That's what we started in. Okay. We started in factored form. We had an R and an S value, which we discovered to be 3 and 15. And S was 15. Okay. Now, what we need to put it into is we need to find the vertex. And in order to find the vertex from this, we're going to be using our axis of symmetry. Okay, so this is our formula for the axis of symmetry. The axis of symmetry tells us that if we add R and S together and divide by 2, it'll give us the x value of the vertex. Okay, so we're going to plug those in for our formula. R was 3 and S was 15 divided by 2, and that'll give us our, we're going to call it AOS. Okay, so our AOS is equal to 18 divided by 2, which is 9. That's right. So when we go back up to the rough sketch of this graph, what it's saying is the vertex of this thing is at 9. So here's our axis of symmetry. We know the axis of symmetry is going to fall at 9 for our x value. We still got to find our y value. So we have our x, we got to find our y. We know this is going to be at 9. X equals 9, okay? Is the axis of symmetry. That's where this line going through the middle of the parabola is. Now we need to find the other part of this. Now what we can do to solve that is we take our axis of symmetry and we plug it back into our factored form. Okay, we're going to plug the x value of the vertex in for the two x's in factored form. So we take y was equal to, and it was negative 2, x minus 3.
Isn't it 9 minus 3?
Yeah, we're going to plug it. We're going to plug 9 in now. I was just rewriting the formula. So now we're going to replace both the x's with our 9, because we know that that's the axis of symmetry, which is also the x value of the vertex. So we're going to get y is equal to negative 2 times 9 minus 3 times 9 minus 15. That's going to give us negative 2 times 6 times negative 6. Does that make sense so far?
Yeah.
Okay. And then we'll put these all together. So negative 2
72.
times, yeah, you're right, times 6 times negative 6 gives us positive 72. That's right. So it turns out that our vertex is at 9 meters away from the wall. The rocket has a peak of 72 meters above the ground. So this is quite high up here. This is apparently at 72. Okay. And what we'll do on the next page is we'll try to get a true graph of this here. Actually, what we can do. Okay, so we have our formula here. Our a value is negative 2, x minus 3, x minus 15. We'll go to graph it. We're going to have to zoom out quite a bit. It turns out, here's our idea of our rocket. Okay. Now we're going to zoom in to find the exact points. This is our graphed version of this. We're going to zoom in a little. So first we're going to zoom in for our vertex. And if we're looking, zoom in even more.
Is it 9 and 72?
Yeah, that's right. So if we take a look here, our vertex, we come across here, this is exactly 72. So we know our height's at 72. We got that much so far. And it looks like this is going to be at 9 if this is going up by 0.5, 8, 8.5, 9. So we have our vertex at 9 and 72. We know that part's correct. The other thing we just want to double check is that our x-intercepts are correct. We'll go down. We really had to move quite a bit here. Probably could have done this faster, but here we go. We know that one of them was at 15 and 0. We got that right. And the other one, if this is going up by 0.5s, okay, so 0.51, 1.52, 2.5, that's 3. And there's our 2x intercepts. So we definitely know we have the right graph when we've gone and graphed it all out, okay? So what we'll do is we'll save this for us. Zoom out a little more. There you go. So there's our graph. We have our points. And okay, question number 3 says, to raise money, some students sell t-shirts. Based on last year's sales, they know they can sell 18 t-shirts a week at $12 each. All right, so let's already talk about that. They know last year, I guess this would be considered their total revenue, so the amount of money they take in. Revenue is equal to your sale price, we'll call it your price, times the amount you sell. Okay, so P is price, and S is how much you sell. They found out last year that at a price of $18, they sold 18 t-shirts at $12. So the price was $12, and they sold 18 t-shirts, right? So we could already figure out how much revenue they had last year. In fact, we know that their revenue last year would be 12 by 18, 216. So that was their revenue last year. But what's really important is this part of the equation right now, okay? That's what's important to us. It says that if they raise the price by $4, they will sell 2 less t-shirts each week. Define the variables. All right, we've done that already. We defined our variables, price and selling. Write an equation for revenue. Okay, that's hard. So what they said is if they decrease the price by $4, so if they go down $4, they will increase 2 shirts. Okay, I put S there for shirts, but it's not really important. What we need to do is we need to actually fit this in the equation. So our revenue equation, R equals 12 and 18. We're going to set this up so it looks like our factored form from before. We want this to look like factored form. Okay? So, because of that, first of all, it says that if they decrease the price by $4, so for every $4 increase, so what that is that's 12, because that's our money, subtracting 4 and X. We don't know how many times they're going to decrease by $4. They might just do it once, that means X would be 1. They might decide to do it twice, so that would be an $8 decrease. We do 4 times 2. And every time they do that, they're going to sell 2 more t-shirts. So that's plus 2X. What that's saying is that for every increase, so this is talking about decreases in money to increase in shirts. So every time we decrease the money once, so by $4, we'll go up once by 2 shirts. If we decide to do 2 decreases, that would be 2 times 4, which would be $8 less. And that'd be 2 times 2, we'd sell 4 more t-shirts. Does that idea make sense to you? Okay. So we have that. Let's move our factor form up here a little. So our factor form looks like that. Now remember what I told you, we can't figure out our R and our S right away because we have variables in front of so we have coefficients in front of our variables. So we have our equation. That was part, I think, like C of the question. What is the maximum revenue they can sell each week? All right, so when they talk about max revenue, what part of a parabola are they talking about?
What do you mean max?
Max. What's the max of a parabola?
Oh, the highest point.
Yeah, the vertex. They want us to find the vertex. Now with the information we have, we're in factored form. We need to get our R and our S, right? So that we can put into the axis of symmetry and find out our vertex.
We need to flip the negative 4x and 12 first?
Yeah, we can move them in different order. That's fine. We'll solve it either way, but we'll do it your way. So we have R is equal to negative 4x plus 12 times plus 2x plus 18. So 2x plus 18. Okay, now from there, I need to actually find my x-intercepts. These are my break-even points. That's what my R and S are going to be. So an x-intercept always has a y value of what? Do you know?
Here.
Oh, x-intercept always has a y value of what?
0.
Yeah, that's right. Because an x-intercept is when we're down here. So on the y-axis, that's when y is 0. We're talking about y is 0. So what I'm going to do is I'm going to replace our r, because r is going to be our y. Revenue will be our y.
And so you have to divide it by 4. Divide it by 4 to get the x.
All right. Before we start setting stuff, or before we start breaking them open, we do know revenue is going to be equal to 0 because we're looking for x-intercepts. Now you're right. I can take a common factor out of each of these brackets. So what could I take out of the negative 4x
Negative.
plus 12?
Minus 4.
Yeah, we can take negative 4 out. And what can we take out of the 2x plus 18? That's right. So I'm going to take negative 4 out of here, and I'm going to take 2 out of here. When we divide them, what do we get?
X minus 3.
Yep.
And x.
We have negative 4 out here. And
outside back is 2, then x plus 9.
x plus 9. So let's just draw this a little neater. We have 0 is equal to negative 4, x minus 3, x plus 9. Now, what this says is, technically says 4 times this, times 2, times this. They're all multiplied together. Okay? I need to get a better a value. In multiplication, there's a rule that doesn't actually matter what order you do multiplication in. As long as you just do it correctly, you'll be fine. As long as they're all multiplied by each other.
Aren't they supposed to be the same?
No, they don't have to be the same. No, because we've taken a different common factor out of both of these. Okay. Now you're thinking of factoring by grouping, which we need to do here. Okay. Now, our common factor, when we took it out, I'm going to show you. I can bring that 2 to the front. We would have negative 4 times 2 times, remember I told you it doesn't technically matter the order, plus 9. I can simplify my a value, or my common factor. What is negative 4 times 2?
Negative 8.
That's right. So oops. We could have negative 8 times x minus 3 and x plus 9. And this all equals 0. Okay? Now, this is where I want to show you how it didn't technically matter. We would still get the same answer. Now remember, I got to isolate each of these brackets. Like I said, each of them equal to 0, right? So we're going to split this in half. We're actually going to split into more than just half. I'm going to set 0 equal to x minus 3 and 0 equal to x plus 9. Okay? This is with our new numbers, we'll call it. Okay? These are our new numbers. And these are going to be the old numbers. They're still technically the same thing, but remember my brackets before, they said, and I'm going to set these brackets equal to 0. They said 0 equals negative 4x plus 12, okay? And 0 equals 2x plus 18. Does this make sense so far?
Yeah.
This is before we took the common factors out. I decided to set those both equal. Remember I said, you asked to take them out. I'm like, yeah, that's no problem. It'll still work. We're going to solve these right now. When I bring 3 to the other side, what do I get? So x is equal to positive 3. And when I bring 9 to the other side, we get, yeah. So here's our 2x intercepts. Let's do it on this side. When I bring 12 to the other side, what do I get? Negative 12 equals negative 4x. And when I divide both by negative 4, I get x equals 3. And same with the other side. When I bring 18 over, I get negative 18 equals 2x. And divide both sides by 2, we get negative 9 equals x. So it didn't matter if I took the common factor out or not, I would still get the same x-intercepts. It's just whatever you feel more comfortable with, whatever you're used to doing. Okay? So we have our two x-intercepts, and we know that they're going to be 3 and 0, and negative 9 and 0. So let's actually go make sense of these on the next page. We're going to graph these, okay? I'm going to at least try to, because that's what the question's asking. So we made a mistake reading this.
So will we get the same answer though, or no?
No, it's going to be a little different. It actually said when we increase the price by $4, writing so small. So if they raise the price by $4, so that's plus 4x, they will sell 2 less t-shirts, okay? So we're going to go through this. Don't worry, there's a little math to solve this. Negative 2. So we're going to go down and just change our answers a little, okay? So I'm going to quickly...
So we wouldn't have to divide that by 4, just...
We could. We'll still use
4.
the same answers, yeah. So these signs are all going to change. They're all going to go backwards, okay? Oh, sorry, no, actually, that'll still be 12. But this will be plus 12. This is plus 4 when they raise the price $4. And in this one, it was minus 2 plus 18. They would subtract 2 t-shirts. Okay, does that make sense?
Yeah.
Okay, so now we're going to go through these. We can get rid of this negative 4. It doesn't technically exist anymore there. and that's just going to end up being plus 3 because we divided by positive 4. So we're going to end up with plus 3 each time. Does this make sense so far?
Yeah.
And then in the other one, because this is negative 2, we actually divide by negative 2, which means this number is negative 2 on the outside, and we multiply by negative 2. We still get negative 8 out there, but the difference is when we divide by negative 2, this becomes negative 9. Okay? So I want you to quickly think as I'm going through this, how's that going to change our answers in the end? Okay? The signs have switched. So instead of being negative 9 and positive 3, what do you think our answer is going to be in the end?
It's going to be going upward.
Well, the two signs are going to switch, right? So our signs are now, this was positive 3, so this answer is negative. This was negative 9, so this answer is positive. Okay? And the exact same thing happened over here when it switched. We would get negative 3, and we're going to get positive 9 here, because this is a negative 2x. We divide by negative 2x, we get positive 9. Okay? So our answer is just, we end up having opposite answers. We have positive 9 and negative 3. Okay? Always got to make sure we read our question. All I did was flip the 2x intercepts. So on the next page, when we go to solve this, okay, so we found our 2x intercepts to be negative 3 and positive 9. Right? So 9 and 0, and negative 3 and 0. Now, the question's asking us for a maximum, which means they're looking for some vertex. We knew our a value was negative. Remember, we took out that 8. So we know we have some parabola that goes like this. We're looking for the vertex. So since we have an r and an s value, we're going to use our axis of symmetry formula. Okay? Does that make sense? So we'll use the axis of symmetry formula in order to solve this. So we'll plug in our r and our s values, which are negative 3 and 9. So our axis of symmetry is equal to r is negative 3, s is positive 9, divided by 2. That gives us 6 divided by 2, which is positive 3. Okay? So we know the middle of this parabola is going to run through the point at x at 3, or positive 3. So this is our axis of symmetry. It runs right through the middle of our parabola. We also know that's the x value of our vertex. So because it's the x value of the vertex, our vertex is going to be at 3 and some value of y. We're going to plug 3 into our factored form. We can use either of them. Remember, we had two of them. We had one which was where we took a common factor out. All right, so what we'll do is we'll actually solve both of them just to prove that they're the same.
I have a question.
All right, so remember, this was our old one, and this was our new one. We're just going to prove that it doesn't matter which one we plugged it into, we would have got the same answer. Now our x value was 3, so for both of the x's, we're going to plug in the number 3. Okay? So we'll do the old one first. Revenue is 18 minus 2 times 3, and 12 plus 4 times 3. Okay? We'll get 18 minus 6, and 12 plus 12. 18 minus 6 is what? Yeah, times 24. Okay, so let's take a look. 12 times 24 equals 288. So 288 is their max revenue, apparently. We'll check it on this one too. Negative 8, 3 plus 3, 3 minus 9. Negative 8 times 6 times negative 6. Put them all together. Negative 8 times 6 times negative 6 is 288. So it didn't matter which version we used, we still got the exact same answer. So our vertex, apparently, is 288 and 3. So in terms of our graph, we're way off the chart here. We're at, let's say it's a broken line.
Which one's easier, the new one or the old one?
It's really whatever you feel more comfortable with is the easiest. We had a parabola that reached up here and came back down. So what they told us, and now this is the important part, x was 3. That means we made 3 price changes. Okay, so let's finally make sense of this. Remember our original question? It stated that if they move the price by $4, to move it up $4, they lose 2 t-shirts. Is that what it was?
Yes.
Yeah. So we started with 12, and we decided to go up $4. How many times? Because our vertex was at 3, right? And our y value was 288. So we're just going to double check this. 3 and 288. So they decided that they were going to change the price 3 times. So our old price was 12. So this is P for price. That's not an R, that's a 2. Plus 12. The new price they decided, 12 plus 12 is what? 24. So that was the new price. They decided to double their price pretty much. They're going up to $24. They discovered that the amount of sales would go down 18 t-shirts minus 2x, which they decided to do it 3 times. So that means 18 minus 6. They now sold 12 t-shirts a week. So that's their amount of sales. Remember, revenue was equal to price times sales. So their new price was $24. And they're now going to sell 12 t-shirts. We already did this calculation on the other page. We know it's going to be $288. So their revenue is $288. So that's how you'd read it on the graph. The max point, our max value is how much revenue they were making, which was $288. And that was after 3 shifts in price. So they may ask us, what was the new price? How many shirts did they sell? We just figured that out in this graph.
These are all the same questions.
Yeah, very similar process. So this was our factored form. We took a look at it. Look at this one. It's even larger. It looks like it zooms up. Yeah, this one goes right up to 288. So it's a very thin parabola, it looks like, when it comes back down. And -3 and 9 were our 2 points. So either way we put it, we still got the exact same parabola. Okay, so there's this company, and they discovered the revenue. Revenue is the amount of money they take in, is represented by this function. And their cost is represented by this function. They want to know a profit function. Now, profit will actually be equal to whatever your revenue is, subtract your cost. Revenue is the amount of money you take in minus how much it's going to cost you to produce that. So what that is we actually try to take our R and subtract our C for profit. So profit will equal, R is negative x squared plus 31x minus 18, minus our cost is 3x plus 6. I did now. So we have our 2 functions. We need to subtract both of them. Okay. So what this is going to read is negative 4x squared plus 31x minus 18. We apply the negative into both. So it becomes minus 3x minus 6. And then we have to combine our like terms.
Wait, why do we do that?
Imagine it's like an imaginary -1 on the outside, and we're using our distributive property. So we apply it to both. So -1 times 3x is negative. That makes sense? So we combine our like terms. These are our x values and our constants. Yep. Yep. So our profit function would be negative 4x squared minus 28x. That's right.
Wait, no. Plus 28x.
Oh, sorry. Plus 28x and then minus what?
24.
Yeah, minus 24. So there's our new profit function. Okay. So that was the very first part of the question. Write a profit function. How many pairs of shirts must the company sell in order to break even? Now, what they mean by a break-even point, those are x-intercept is what they're talking about. We're going to have some parabola. We know our a value is negative, so we know it's going to face downwards, right? So we have something that looks like this. It's going to have some parabola that goes like this, something like that. And break-even points are going to be here when it's crossing an x-axis. We don't know for sure. That's just a rough sketch. But we know it's going to cross the x-axis. So in other words, we need to turn this into what form? Right now we're in standard form. Yeah, that's right. We're in standard form right now. We're going to have to turn it into factored form. So standard form, and we need to go into factor form. So we're going to have to factor this whole function. Now, in order to factor it, what are our steps? What do we need to do? What's the first thing we need to do, at least?
Isolate x. I know x can't be.
Well, remember when we're factoring, negative 4x squared. What's the very first step to factoring? We look for the greatest. Yeah, that's right. So let's look for our greatest common factor here. What will the greatest common factors be here? Just 4 or what? Yeah, let's take negative 4 out of everything. That way we're working with a positive term, right? So our profit function is equal to negative 4x squared minus 7x plus 6. Okay. So we have our a value. We figured that part out in our factor form. Now we've got to factor this term. So what are the factors of x squared?
Wouldn't it be x 6 and 1?
Yeah, you're right. Right away, you were able to tell. It's going to be 6 and 1 for sure. We got to add them together to equal negative 7x.
So it would be negative 4, then x minus 6, and x minus 1.
Yeah, that's right. They both have to be negative to get to that. So that means they both have to be negative here. So our profit function in factored form is negative 4, x minus 1, and x minus 6. Now we still have to find break-even points. Break-even points is when profit is 0, right? That's when we break even. When however much money I make is the exact same amount as how much does it cost me. So if profit's 0, right, this is where we have to split our function. X minus 6. We have to split these, put each bracket equal to 0. Does this make sense? So when we split this, 0 is equal to x minus 1, and 0 is equal to x minus 6. Okay. Now that we have that, we move 1 over, we get 1 equals x, and 6 equals x. So according to this, when they sell one, oh, it's in thousands. Oh, so that's a very important part too. X is in thousands. So it's when they sell 1,000 of their clothes or 6,000 of their clothes, they'll break even. Okay? So on our R graph, we're going to have 1 and 6 as our x-intercepts. But when we go to make sense of this, their break-even points, they have 2. So BE points, we'll call them, break-even points, are at 1,000 pairs of clothes and 6,000 pairs of clothes. Okay? So we have our factor form. That was the whole point of this. From there, so you're right. Because they're asking for max profit, they want the vertex. We know our points are 1 and 6, or our R and our S at least, which means we're going to need our axis of symmetry formula. So we take the axis of symmetry formula, and we're going to be plugging in these values here. So we get 1 plus 6. Yeah, that's going to give us 7 over 2, which is, you're right, 3.5. So if I had to put that in thousands, yeah, that's right. They're looking at 3,500 in terms of clothing.
We have to put it in thousands?
Yeah, because that's why they said X was in thousands in the question. So we have to make sure it's in thousands. Now, we use the basic number, 3.5, 1, and 6. But our final answers, we're going to have to multiply by 1,000 because it's in thousands. Now, since we have that, we use our formula we had before, our factored form before. So our profit was equal to, let's go take a look at how our factored form was in the other question. What did we have in our factored form? Negative 4x squared minus 7x plus 6. So let's remember that. This was our profit formula. So the profit formula read P equals negative 4x squared.
Wait, you should substitute it in?
Yeah. Plus 6.
Say y x squared. Oh, never mind.
That was we had it. Oh, sorry, that was our standard form. Sorry, that's our well, partially our standard form. We actually want the factor form, right?
Yeah,
So sorry, you're right. It became x minus 1 and x minus 6. Now I could plug it into either of those. We'll still get the same answer, but let's do our factor form. So we're taking the number 3.5, which is our axis of symmetry, remember?
Yeah.
We're plugging that in for both the x values to find out what the vertex, what their profit is actually going to be, what the highest profit they can make is. So we have negative 4, 3.5, 3.5 minus 1. 3.5 minus 6. Okay. So we get negative 4.
2.5.
2.5. And what is this?
2.5 again.
Negative 2.5. That's what's important. We're going to multiply these together, okay? So we get
Negative 20.
negative 2.5 times 2.5 times negative 4, 25. And that's also in thousands. Okay? So our vertex, or the max, is if they sell 3,000 clothes, how much money will they make?
2,500. 22,000.
Well, $25,000. That's if they sell. That's at their max profit.